Welcome to another tutorial. In this tutorial, I'll be showing you how to compare machine learning modules. We are going to look at the different machine learning modules that are there. We will compare the different machine learning modules. The first one, which will be logistic regression, and then the second model, which is going to be the KNN, which means it's the K nearest neighbor. And then we will also look at the SVM, which is support vector machines. Then we will also look at the naive Bayes, okay, which is the Gaussian naive Bayes. Okay, then we will also look at the comparison. We have already under decision trees, which we can also look at it. Then we can also look at random forest. So these are the different comparison of the models that we want to look at it. We want to look at the performance of this model in terms of accuracy and in terms of performance. So we want to see which model is more accurate or performs very well. Then we will also summarize it with the last one, which is going to be the confusion matrix. The confusion matrices. So these are the different machine learning models that I want to cover in this episode. I know the discussion is going to be lengthy, but please make sure that you follow along. I'll try to explain each code line by line, and let's dive into the practical bit of it. Remember, I'd already given you the data set. This data set had disease.csv. This is the data set that we will continue working with it throughout our series. First, we need to learn how to import our data set, which is something that we have already done before. It shouldn't be something which is very difficult. We will just import our data set and then proceed right away. But before we'll go with the data set loading and reading, there are libraries that I need you to always put. I've already talked about some of this library. I'm not going to consume a lot of time here. I just want us, because we already have it somewhere and we could reuse some of this code. So let's begin by import libraries. You've already worked with these libraries, so these are the libraries which are there. You will import NumPy, which is as NP for linear algebra, pandas for data processing or manipulation, matplotlib for plotting and data visualization, Seaborn and CN, which is statistical data visualization. And then we can also import the machine learning regression, which is going to be the logistic regression from the linear model. These are the different modules that we looked at in our previous lesson. Then you can control the display of your background, of your visualization of the data if you want. So I'm using this kind of gray code. You could check it out, and then I want you to ignore the warnings. Now let's start doing the work. I'll explain all this, but this is a part which we already covered. So let's begin by loading. This part I will not waste time because you already know something about it. Read the data set. Now to read our data set, we just do df pd dot read underscore, then you put the file name, which is going to be basically hat underscore disease CSV. we don't want it to pick any heading for now. We'll just do df.head. So this head method will return the first 5 head. So when we load this data set, we'll see the first 5. Which environment are you selecting? Select the kernel. So you pick Python 3.10.6. Then you load. Now it's saying that we're trying to see df. Okay, it's just trying to show us some small error here, which it's something that can be fixed. Maybe if you have not written the spelling correctly, but you can check it out and have it fixed. So what's the error all about? PD is not defined. Okay, because we did not load this, we need first to load this to import the data for manipulation. When you don't load this, then definitely pandas will not be able to process your data. Now we can now go ahead and load the data. So this is now fine. Now our focus, because we already dealt with this data set before, I just want us to explain a little bit more about the columns of this data set. Okay, we'll just look at the columns of this data set. I've just said that this data set contains age, sex, CP, all this we could have already worked this a little bit earlier with you. So this contains the summary of what is in the columns. Summary of the columns. Now we have the CP for chest pain, trace BPS, resting blood pressure, and so on up to the target. Now the target is where our data set will be normalized from, where we'll have our remember, when you're creating a linear regression, you need to split the data, one for training and one for testing. So the one for testing is the one which is going to be our target. Then the training is going to take the bigger percentage of the data. Now let's begin with our first part of the module that we want to look at, which is going to be logistic regression. Now we will begin by looking at logistic regression. Logistic regression is a statistical method used for binary classification. The goal of the logistic regression is to predict one or two possible outcomes, either 0 or 1, usually represented in terms of 0 and 1. So how can we try to look at those possible outcomes based on one or more input variables? So we want to use all these input variables of age, the one which are, all of them are in terms of the numerical data. Remember I talked about the categorical data, where we have numerical category and then ordinal data. But the data which we're going to deal with is numerical, which can be used. Now let's try to show maybe to 20 columns here. So to 20 columns, when you look at this data in terms of 0 and 1, you realize that okay, this part and these ones, sex, CP, FB, PS, exon, these are the data that can easily be used for what? For our training. And we can use target to be our testing data. So this is what I wanted to show it to you, so you could see them in terms of 0 and 1. Or alternatively, we could look at this type of data. Let's try to do a count of this type of data, which are in terms of 0 and 1. But as we discussed, the logistic regression basically focus on the data which are in terms of the goal is to predict, okay, predict one or more possible outcome. So usually represented by 0 or 1, represented as 0 or 1. So this is what we're going to do. First, let's do a count of the possible column targets that are there. Okay, so let's try to column target. So we want to know the number of zeros and 1 which are there in the column target. So you do df dot target is the column, target dot value underscore count. So this count method will help count the values which are in the target. So when you run this cell, you would see that our target contain the 0 are 499, the 1 are 526. So 1 is 526, 0 is 499. So this is our target that we want to test from. Now another thing that we can now focus on to make our analysis more important, we could try to look at the mean of this data. Let's try to get the mean. Get the mean. Now to get the mean, we could basically use a grouping. So we can group a df group by. Now what do we want to group by? We look at the column for target, then we try to get the mean. Now this will only show us the mean of all our columns, okay? Then we will look at it in terms of the grouping, which is going to be in terms of the columns. So you could see these are for all this other data that we are going to use. So we get the mean for, I would call it mean for our training data. Okay, that is well represented. Now I want us to move a little bit and then look at one more thing which I feel it's going to be important. I've already tried to look at that focus, but we could look at this in terms of maybe let's try to have those ones with heart diseases versus we could create a scatter plot, which is not basically needed right now, but we can just try to do that. So let's create a scatter plot for heart disease versus age and maximum heart rate. We could write this by first say PLT, which is for plotting. We've imported that module from the matplotlib. Then scatter. Now the scatter method, we can pass in our parameter x. We haven't defined our parameters. But we would just say X, then in our data frame X equal to df in our data frame age. Now what are we looking at from age? We're looking at df to target. Now in the target column, we want to say target column is equals to 1. We want to see 1 is those with add diseases, 0 is those without add diseases. So that's why we'll use that 1. Then this one we can just proceed and try to make it, then the y of it will be the one of data frame, which is a df. We want to look at this other column, the talak column, and then we're going to focus on df dot from our target equals to 1. Then we can now focus and look at the color, the C, which is going to be for color. Now I've already used this color code before, so if you use it you will get something yellowish in color, FFD700. That's the color code. And then you can also use another color code which is going to be in the next data. So we can do label. So we want to label that color code to be with what? Disease. So this basically just shows us that this particular color code contains the disease. Now we can copy this code and we reuse the code, but we just change the parameter here. This time round we'll look at the one without diseases, which is going to be 0, and then the color code we can change it so that it can contain another color code, which is going to be like a kind of green, A D F F 2F. It's going to be green. So here we can say not disease. This is just a label. Don't worry about the parameter so much, but you would see it when we do our visualization. Now for every visualization you need to add a legend. Add a legend. Now we do plt legend using the legend, and then which legends are we going to add? Let's add the labels to the axis. Okay, now the axis, which is going to be basically the x-axis. Okay, now with the x-axis we could do plt dot x label. Then what do we want it to show? We want it to display age in the x-axis, and then plt dot y label, which we want it to be, the y label is going to be maximum heart rate. Maximum heart rate. Now remember, I also say that it's important to put a title. Okay, set the title. Now in the title of the plot, we can just say plt.title. Now what title do we want? We could just say heart disease versus age and maximum heart rate. Okay, now to display, just show the plot. You do plt.show. Now when you run this code, it's saying that the other code is not a valid code. This code here for this code FFD700 is not a valid code. Okay, so it's not a valid code because we did not put the hash. All these codes begin with the hash. When you run, you could see the changes. So those are things that are easy to fix. So we did not put the hash. Remember to put the hash. So that's how we could get to the what? To this scatter plotter. But you could sometimes try to draw to plot to see the kind of correlation in this scatter plotter, but that's not what we are going to do now, because our focus today is quite different on this data set. Our focus is basically to use the machine learning modules that we have talked about, and we are beginning with the machine learning modules to help us create basically, let's first work with the machine learning models to look at the accuracy of these modules dealing with this data set. But from the scatter plotter, it can give us an hint: those with heart disease, those without heart disease. How can our model test for the accuracy of this? That's what we want to focus on. So with the logistic, we're going to begin just basically create a logistic regression. Now, for us to create a logistic regression, it is important to solve. You know very well that logistic regression helps in solving problems with classification and classification. So in this way, we could also look at its importance. We need first to create the independent variable and dependent variable. So the dependent variable is going to be the y. The x is normally our dependent variables that we have. So let's write this simple code first to create the logistic module. To do that, we would say our y, which is basically going to be our training data set, which is going to be the independent variable, to df dot target dot values. Okay, the value is just to deal with the values which are in that column for target. Then the x underscore, we could have data, because this x data drop df dot drop. The drop is basically to help us normalize our data in the target category. So the pass in the parameters of drop method, we can pass in the column for target. Now, what are we looking at? We're also looking at the axis, which that axis is just only one axis that we're going to focus on for it to normalize the data. Now once it normalizes the data and you run this, you realize that when you hover over it, you see there's that breakpoint here. Okay, but I don't want to create that breakpoint. Now in the next line of code, we could also improve it, the normalization, by normalize the data by just making it to have the minimum and the maximum. So which we could do x to be literally, you won't see the changes right now, but I'll show you how the changes can be, which could be x equals to our passing the parameter in the x data minus np dot min, which is for the minimum value into our x data. Then we're going to divide this with np max of data, then minus np of minimum. Now when we run this, you won't see the change, but it is going to help us when dealing with our data. Now the first step that I talked about is when you're creating any data, you need to reserve some bit of the data for training and some bit of the data for testing. Now the bigger percentage of the data will be for training, and then the smaller percentage of data will be for testing. We can split the data. Of course, we have covered this somewhere. Split the data 80% for training and 20% for testing. Now what you're going to do is, first, before even you start splitting the data, you need first to store the different variables of your data. Now to store the different variables of your data, you need to focus on one thing. Let's try to deal with it in this approach. We are just going to store the data. We know x train is for our, is going to be for our training, then the x test, then x train, x test, y train, y test, and now our y test, all these variables to be equivalent to train test split, which is one of the modules we imported for splitting the data into training and testing. Now in the train test module, we're just going to pass in the parameter for x and y. Now the x and y, we would get the test size of our data, which is going to be 0.2 according to the data that we because the 20% you need to convert it, which is going to be 0.2. Then you do the random state to 0. Now the importance of the random state is for reproducibility of our modules that we need to use. Now when you run this, you realize one thing, that when we say train test split, we've opened and we have not closed it. Okay, there's just this one, we open it twice, so that could fix that problem. Run, no error still, we're moving well. Now from this point here is where we already created, we have done the splitting of our data. Now we're going to do transpose matrices. The transpose is basically to transpose our X-train and X-test modules. So let's do the transpose matrix. I've already explained this earlier. So the transpose is basically for transposing our transpose matrices. So we'll have X underscore train to X underscore, then dot T. The T will be for transpose. Then we can also do it for Y train dot T, then X test dot T, and Y train dot transpose. So our next line of code, which is going to be we will now focus on the logistic regression. I told you, like, when you have run this code from up, you could basically now try to look at the accuracy of the logistic model. So here what we imported, it's important, we just want to determine just to get the accuracy using the logistic regression. But of course it's going to be the logistic regression classifier. But let's first do it with the logistic regression, which is going to basically give us the accuracy, the test accuracy. Here, get the accuracy using the logistic regression. Getting the test accuracy. Now for us to get the test accuracy, it's a very simple thing that we need to keep following in our code in order not to mess up in anything that we'll be doing. Okay, so let's try to implement that with the test accuracy. So for logistic, we will say accuracy, the variable accuracy. The variable accuracy will pass it to an empty dictionary. Now the empty dictionary will help us to get the X train and then Y train and test. So let's do the LR. LR variable here will be for our logistic regression equals to logistic regression. When you do a method of logistic regression from what we imported, this logistic regression will just get the class for all the logistic regressions. And then we will also do the LR for logistic regression. But each and every time you do the logistic regression, you need to fit your model, because there's also overfitting when the model doesn't perform. It performs poorly. So we can now get here the X train. Can get the X train and the y train. Y train. So the x train, if you're fitting it, would use the transpose matrix of our data. So we use the dot t in the parameters. Now this is just for fitting our model. Now to get the accuracies, just do accuracies, then we will get we'll just get the accuracy. Could just get it from the list to get the logistic regression, and then to get us basically our SCC, which is going to be for accuracy. Then let's abbreviate it. Okay, now we abbreviated it here, but we'll try to define that. It's defined, but we'll try to reuse it somewhere. Okay, so let's see how we can implement that. So we want it to, when we do a print output to two floating points, we should be able to get the accuracy score. Okay, now let's try to get the output. Get output. To output anything in Python, you can use the print method, which you can pass in the variable. Okay, here basically we want the text. When you put it in quotes, we will get the test accuracy to give us the accuracy. But what we need to do when you have the test accuracy, because we want the test accuracy, then could create some dictionary to get the test accuracy to two floating or two decimal places, which is just two float. And then you could use the percentage symbol now to just show the percentage after the floating points. Now here we could just use the format. Could use dot format to just get the accuracy, which is complaining, which is not defined. And yeah, we close the bracket and we close again. Now we still have that problem of accuracy not defined. Now let's try to define our accuracy here. Our accuracy could be, get us this time round the logistic regression score. Now the logistic regression score is going to be of our y test. This is where the actual calculation takes place. So the y test dot, the one of the dot transpose, then the y test, then y, no, the y test dot t transpose, then the y in this parameter, it's going to be y underscore test dot transpose. Now we will multiply it times 100. Okay, so this solved that problem. So when you run this should just return for us the accuracy in our output, because it will call the accuracy variable. So let's run. Now we have some error here of getting our score, because we have decided to use both y, but it should have been the x test and the y test. So this formula can definitely give us the accuracy calculation. Correct. So that is already fixed. You could try that, and sometimes if you run into error, you can always debug that. So we have our accuracy test, which is our model. Our model test is 72.68. 72.68 using the logistic regression. Now we need to try it with the k nearest neighbor, the KNN classifier. So let me try to show you how you can try it with the KNN. So this second part, we would try to basically first we need to check if we have now you realize here we do not have the module for the k neighbors classifier. So it's important we import them, okay, the library for k neighbor. So first import the k nearest neighbor KNN classifiers. Okay, to get basically to get accuracy score of the k nearest neighbor algorithm. Okay, so what we're going to do is first to import from the sklearn then dot neighbor, then import k neighbors, k neighbor classifier. That is the model that you need. Then from there we can create a variable for KNN then we get the KNN classifier class. Then we will also need to do the fitting, KNN dot fit, like we did with the logistic regression. Don't forget to pass in the variable for xtrain, because we first train the data, xtrain dot t, and y train, because we're basically doing the training. So it's going to be y train dot transpose. Now we need to create our variables to do the calculation. That means it's going to do a prediction dot knn. It's going to be knn predict. In the predict, we shall pass in only the test dot transpose. Now, to get the output, display get output display. We could basically do a print, which is a normal thing. Then inside the print, we pass in the parameter. Let's say we have a parameter for empty. Then you can do NN, which is just nearest neighbor score. Remember, this is not yet the maximum score. We just first want to get the nearest neighbor score. Then we could, inside the dictionary, we could just do it to two floating points. Just do 2f, and then we put the percentage symbol because we want it to show it in percentage. Then we do a dot and we format then to knn dot score, and then the score method can take in the parameter for x test transpose and y test dot transpose. Now what we could do here is basically, since we have done the format, we could try to get the calculations times 100. Okay. Now, when you try to run this print, we get print format classifier missing. So we can check this out if we have our format classifier written very well. This doesn't make any change, but we could just check here and see. 12 dot format to knn score x test y test to that. Okay, looks like the format classifier is not there. So how can you fix that? We just need to go to our knn and then pass in the classifier, which is going to be n neighbor 2. Now let's run one more time. Format specifier missing. Now it's in the last line of code. Okay, how are we going to get this to get our display? Because we wanted this basically to get us to the n neighbor means for for k. Okay. Missing precision. Okay, so it's basically missing the precision which we need to get it working. So print format xtrain xtest okay. How are we going to get this solved? Briefly, this code here, missing precision. So let's see how we can rewrite this. So basically the precision is now right, so it can get for us the NN score. Print, so it's just print n score, so it gives us the accuracy of the score of which you could say that is not yet the maximum score. Let's try to get the maximum KNN score. Let's try to get the maximum KNN score. So how are we going to get the maximum KNN score? So we want to get the maximum KN score for the module. So we will do score. Remember to always write your code using the snake case. So score underscore list, then an empty list there, then for I in range, what's going to be the length, the range? It's going to be 1 to 20. Then we will get the KNN of, because we already have the KNN, can make this to be 2 KNN. Then we could do, yeah, following the other, can just get the K neighbor classifier. Then we just do the n neighbor to I, basically to get, we could use this. Get the n means, okay? Then you could do the KNN2. Then we try to fit the model, which we can use this. which is going to be x train x test basically. We have a problem here. We can fix this. Now we can get from our score list, then append our KNN2. Okay, let's just not use the fit. Let's append the KN2 score. Then we get basically the x train in the parameter, x train x test transpose. Then what we can do right now is we can basically try to get the SC, then we could even plot. Let's plot the plot line let's plot the line. Let's get a line plot. Show using line plot. Okay, so to show using the line plot, we're just going to use plt then dot plot range. The range is 1 to 20. Then we could get the score list, not the type, just score list. That should be enough to get for us the plotting. Then we could plt dot x ticks. Then the ticks are going to be basically arrange into 1, 2, 1. Okay, it looks to be a little bit not, because we're not using numpy to. So if you use numpy.np, the arrange method would definitely work. Just here we have double quotes. Okay, so that is okay. Now maybe a little explanation on why I'm using this. So this is basically going to plot the scores in the list and then print the maximum score of the KNN. That is what basically that line of code will try to get for us. Okay, now we could now go further and do the plt. Remember, this just to create what can be stored. So create plt dot let's try to get the labels on x label. The x label can be the k value, and then the y label can be the score. Then to show, of course you now know it, I don't need to repeat this, just plt dot the title, which is just going to be maximum, but you have to put it in quotes, maximum KNN score. Then plt dot show, just to show us the graph. We also need to get maximum KNN score in percentage. Now what we just do to get the accuracy equals to max, then score list times 100. Then you could get the accuracies. So the accuracies can be KNN in the list to ACK. Then let's get the print. The print for output, which is going to be maximum KNN score is, then we create a dictionary to get to 2F, then format to ACK. Okay, so that is it. When you run this line of code, it will generate for us this graph. Sorry, it was slow, but now it is. So this is the line graph which shows the maximum score. So literally we are able to plot the score list, and then we are able to print the maximum score of the KNN model. So this is the maximum score. It is the title. What did I write? Maximum KNN score, maximum KNN score model. So that is the maximum KNN score model. Now these were the K values, and we were able to get this. So the maximum KNN score value is 100. We didn't put it in percentage, so we could just fix the percentage symbol here to show us the maximum score in percentage. So now the maximum score to 2DEF is 100, which is a good thing. Shows that KNN is performing better than the logistic regression, which, you see, when you try to get the KNN without getting the maximum score, it was 95.12. Now the logistic regression is 72.68. So the KNN model is performing very well in this case. Now let's move to the next model. Now in the next model, we'll try to use the SVM. Okay, now for the SVM, which is the support vector machine, we'll also try to see if we have the SVM. Now this time round, we are going to get accuracy. We are going to get test accuracy, using the support vector machine SVM algorithm. Now what we're going to do, we need first to import the module for SVM from sklearn. sklearn dot, for SVM you just write SVM import SVC, which is support vector classifier. Now the SVM variable will store the SV of a random state to allow reproducibility. We talked about it, so it should be an easy thing now. Then could just try to make it always some space there. Then you can also get the SVM to fit. You always have to fit the model to x underscore train, no, test, no, it's train, x underscore train dot transpose t, then y to train. Then then we can also get the accuracy to get the calculation of the SVM, which is just going to be SVM support vector machine dot score x train times 100. Then the accuracy just want to get the accuracy from the list of the KNN. Oops, this time round we are on SVM, I mean support vector machine to ACC. So this variable will store this to get the calculation. Now for the accuracy, what you can do, we could just get the print just to display to show us the accuracy. So which is going to be test accuracy of SVM algorithm. Dictionary, then to two floating points percentage. Then we can format and close the bracket. Okay, let's run. So we have the test accuracy of you have the test accuracy of the SVM, which is the support vector machine, which is funny that here it's performing at what? At 70.24. Always the support vector machine algorithm does not always perform very well. Let me run it one more time and see if it will this time change the performance. The performance doesn't change. Okay, now we can now go ahead and look at the naive Bayes algorithm. So we get accuracy using the naive Bayes algorithm. So how can we do that? So we need first to import the module from sklearn dot naive Bayes, then import the Gaussian naive Bayes. So that is the model that you need. So when you use NB to represent, NB will just be the variable to represent naive Bayes. To store, basically we will use it to store the accuracy of the SVM. Okay. So we will just do of the NB. So we will just basically write the NB, which is going to be the Gaussian NB for storing. Then we need to do NB, which is naive Bayes, then do fit. So we'll just basically try to evaluate the Gaussian model onto the test data. But let's first do the xtrain. So xtrain dot t, just for fitting, xtrain ytrain dot t. Then we could get the accuracy from the dictionary. So the accuracy which is basically going to be nb dot score. Now in the nb dot score, we basically going to do the testing. Okay, so we'll just do test and y test times 100. Then we could get the accuracies, of which these accuracies just stores the Gaussian naive model dictionary. So let's get that clearly. And naive Bayes accuracy arc. Now what we would do here is now to get our output. So we just do the print accuracy of naive Bayes, then from the dictionary to get it to 2 floats, and use the percentage sign. Then we do dot format accuracy. Then you close the bracket one more time. So run this, we get the accuracy of naive Bayes, which is 85.37% in terms of the performance. It's not performing well compared to the other models that we have looked at. Now we could also go and look at the model using the decision trees. Let's look at the model using what? get accuracy using decision tree module. To get the accuracy, of course, with the decision tree, if you do not have the sklearn for decision tree, you need to get, but you use the decision tree classifier. So if you do this, you would get it wrong. Just sklearn decision you just need to do sklearn dot tree import decision tree classifier. Then the variable can just be DTC, which is decision tree classifier, to get the variable for decision tree. Now this will import from the decision tree classifier, will get the class for decision tree classifier. Now each and every time you need to fit your model, which is going to be decision tree classifier dot fit. Then the fit will contain the X train dot T and then the Y train dot T. Then we can now try to also get the accuracy. We have done it a number of times, so this should be much easier for you. Now equals to the DCT score. So we want to get the score, which is going to be basically the X test dot T close times 100. Accuracy then just basically say decision tree for accuracy. Then we could print, then pass in the parameter for, just to give us the decision tree text. Then to 2 in the dictionary, 2F to 2 floats percentage. Now in that parameter you dot format to accuracy 1 2. Now when you run this, you would get the output of the decision tree. Decision tree also gives us 100% accuracy. Now let's look at one last model, and then we can now use the bar plot using the seaborns to visualize and see the accuracy. Now we could also do that using random get accuracy of random forest algorithm, random forest classifier classification algorithm. So let's see. You also need to get the module from sklearn dot ensemble. Okay, import random forest classifier. Then you come with the RF, which is the random forest, which will be random forest classifier, then to the n estimator of 1000, then the random state to 1. Now I'm going to try to explain, but it's easier. We're just getting a variable to store the random forest classifier. The only thing maybe I need to explain there is the I need to explain only the estimator, which basically takes the parameter of 1000. So the random forest classifier will set the estimator to a parameter of 1000. And maybe basically why I use this is to create the instance of the random forest classifier. Then we could now proceed and write our next line of code. So the arrow fit, which is normally the random forest dot fit, say that fit our model to x train dot t and y train. So the arc to be the RF dot score, which we've done it before, which is just going to be x test times 100. Now the accuracy, we have done this before. To random forest classification. Okay, we could just change it like this. Random forest algorithm accuracy score. Okay, let's try to I think just made it in the wrong way. It's just supposed to be random forest. For accuracy. Then we can now get our print. Which is going to be random forest algorithm. Random forest algorithm accuracy score. So put it before. Okay. 2.2 f to 2 floats. So dot format arc. Okay, let's run this. So the random forest algorithm accuracy is also 100. So we have 100 for random forest algorithm accuracy. We have so we've been using this basically to help us get the accuracies. We'll try to use this in our next line of code when we are plotting, just for labeling. That's why we try to use this. Okay, let's now try to visualize our graph. So the random forest is 100, decision tree is 100, it is the Gaussian knife base, which is 85.37. The support vector is 70.24. KNN is 100, and then the we'll try to use that to get the accuracy of these modules. So let's see what we can do with our next line of code here. So we are basically going to what? Compare the modules accuracies. Using the bar plot from SNS, which is the Seaborn. So it's going to be easier. First, we need to just pick colors that we want to display. I already have some pre-colors that I can pick. I don't want bright colors, so always use the hash. So the first color I want to use is going to be 0088 BB. The next color I want to use is going to be 22 8B22. The next color I want to use is 5F9EA0. And the last color I want to use is OFBBAE. That is it. Those are the colors I want to use. I want to use about I even have less. I need, because looks like we have about logistic regression, KNN, SVM, so we need more too. 1, 2. Good. Okay, let me get more colors. So the next color can be, we have the 8. We have the 8 to, okay, let's get another color, the D AA 520. Then the last color, which could be the CF C60E. Yeah, just close the quote here. So these are the colors that I want us to use. Could write red, blue, but I don't like those. So I hope these colors are good. We will see it. So we can now say SNN dot set style, which is going to be a white grid. That is it. in that parameter. Just need a white grid. Then the plt dot figure, we want to control the figure size. Then we pass in the parameter for figure size. Which is basically going to be 16 and 10. Let's do 16 and 5. Or we do 14 and 5. Then we can also get the plt dot y thick to np for numpy to arrange 0, 100 and 10. So 100 is basically to get the score to 100. Okay. Then we also going to do the plt for plotting dot the label, which is going to be the y label. It's just going to be accuracy. Accuracy in percentage. Then we're also going to get the plt dot x label, which is going to be the algorithm, ml algorithm, lm model algorithm. Okay, we miss one, which is the plt dot title, to give us the title, which is just basically compare. This could even be our title. Be sure to put it in a okay. Then the snn dot bar plot x, we pass in the parameter for plotting the bar plot, and list accuracy, which is supposed to get for us all the accuracy, dot key then y list accuracy dot value, then plate for color to colors. Okay, so when we do plt dot show, this should basically show us a bar plot for all this model accuracy. Let's run it and see. Okay. 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 Okay, we have one invalid color that we have. This first color here is invalid, so it's going to be supposed to be like 5. So the B's are 3. This fixed this problem. So let's run it. And let's run this. Okay, cool. This has successfully worked out our modules. So we have the module, the ML modules, modules algorithms. So the MN modules algorithm. So we have the performance. So you could see this performance in terms of percentages that we plotted. So according to this, you realize that KNN, decision tree, and random forest performs better than the SVM, naive Bayes, and the logistic regression. So if you're going to pick any model that you are going to use for training your data, you would rather go with the KNN, decision tree, and then the random forest. But the support vector machine kind of tried to be an old, outdated. I think most people don't like using this module when dealing with their machine learning. In most cases, so you can see which model works best for you, but you can try to compare all these 3 models. So this is how this module works with the data set that we have trained it on. Now, the last part of our training is on the confusion matrix. Let me handle it so that I can have it all done. So with the confusion matrix, we just want to see the performance of these modules basing on heat maps. So we're basically not going to look at it a lot, but we're just going to see the performance of the model, basically just using the confusion matrices to look at all this performance of all these modules, the logistic regressions, all these other modules. So let's write that code to get all these modules for the confusion matrix. Of course, I've not explained the confusion matrix to you, but briefly what the confusion matrix does, I know you could just go and read more about it to help enlighten you. Me, basically, I just wanted to do this practically with you. But just for you to know, ML confusion matrix. So it's basically just a table that evaluates. This basically just evaluates evaluate the performances, the performance of a classification model. So basically about the confusion matrix, just to let you understand more, the confusion matrix is just to view the model prediction by comparing the predicted class to the actual class in the test data set. The confusion matrix is actually useful, especially if you look at the imbalanced data sets where one class may dominate the other class. So you will end up getting the true positive. So to save a little bit of time, the confusion matrix tends to handle this. Because my recording is a little bit longer, I'll just give you this text. You read more about it. So it does more on the true positive, the number of instances correctly predicted. Then also gets correctly positive, correctly classified as positive class. Then true negative instances are predicted as classified, and then the false negative predicted as classified. So this is what the breakdown. So it will just get the actual positive and the actual negative of true positive and false negative. Predicted negative, which will be the false negative, and then the true positive for true positive, and then the false positive for true negative. So basically this is what the true negatives, TN, the false positive. So we're going to look at this algorithm in terms of their predictions, but they are normally used using the F1 scores, specificity, the ROC curve, which is the receiver, also being used under the receiver, and then the receiver operating class characteristics. So you find a lot of the confusion matrices being used in this area. So the ROC, which is ROC curve, the receiver operating characteristic, and then the area under the curve, the AUC, which is area under the curve. So it's area under the curve. That's the AUC. But let's just try to look at the confusion matrices in this particular case, because the confusion matrices just allows us to understand how well the model is performing and identify specific areas of improvement, especially when it comes to dealing with imbalanced data sets, or when different types of errors have different costs or consequences. Those are the areas where we apply confusion matrix in. So let's look at this confusion matrix with our name, with our ML. Okay. So get confusion matrices to look at the imbalance data set. Okay, so first we will get the predicted values. The predicted values. Now our predicted values are the y head for LR, which is going to be logistic regression, going to be LR dot predict. What are we predicting? We're predicting in the y test. Y test dot transform. Then pretty much we're also going to look at the KNN 3 now, because we have used the variable for KNN2, which is also going to be for K nearest classifier, our N for getting the N neighbor means to, let's say, 3. Then also to get, we need to fit the NN3 dot fit. Then you can pass in the parameter for X train. It's train. Then Y y train dot t. Then you can also get the y so we'll do this for all the algorithms that we have used. Y train head dot knn so it be knn 3 predict x test. Then you can also do the y head, the variable for y head. So we have the LR for logistic regression, we have the KNN, so we need also for what? The support vector machine, which is going to be predict it's just going to be svm dot predict. Then we're going to use for naive Bayes head underscore nb equals to nb predict test. Then we're also going to do the y for head, which is going to be dtc predict underscore dot test for decision tree classifier. Then we can also have a variable for head underscore random forest. Okay, now that we have the predicted values here for KNN, SVM, NB, the LR, so we can now go ahead and make our confusion matrix. So we can now import module for confusion matrix, so which is going to be from sklan dot matrices import confusion matrix. Then you can say confusion matrix for logistic regression to be confusion matrix, which is going to be y train, supposed to be y test, and y head logistic regression. So we'll do it for all others. So confusion matrix for KNN which is going to be confusion matrix for y test, add knn. Then we use confusion matrix for SVM, then SVM, then confusion matrix for naive Bayes, y test, naive Bayes. Then confusion matrix for decision tree classifier, decision tree classifier. Then confusion matrix for RF, random forest classifier, edge, random forest classifier. Okay, that's cool. So we have already imported, we have created the variable to store all these confusion matrices. So the next step is now to do the plot. For us to do the plotting, plotting for plotting for so we are going to plot for heat map using confusion matrices. So how do we plot that? We could just do one at a time, then later replicate. So which we just going to get a figure, then we do the subplotting so that we can get. But we want to plot all of them in the same. We don't want to have very many heat maps. Just want to have only one figure for heat map. So we could do that by saying plt dot figure then we will pass in the figure size to take 24 and 12. That's just a half of it, which is okay. Now we want to start getting the confusion matrices in all those, the size of the confusion matrices. So the plot subplot confusion matrix so let's get a font size. Font size to be 24. Then for the subplot this is going to be for super title, which is just going to have that word confusion matrices. Okay, so the subplots are going to have then just to adjust by itself to fit other heat maps. So we just pass in adjust for the white space to be 0.4, and the H space to be 0.4. So that's the width and the height. So what you have decided to pass here in the parameter to make them not very big, but to the size of the width 0.4, the height 0.4 for all the subplots that you're going to get. Okay, now we can now start plotting. Once we get one, we can just replicate the code and then just change a few things, especially for the titles. So the code is just basically going to be the plot, subplot, which we want it to do 3 by 1 in the parameters for the plotting. Then we'll do a plt dot a title. Now this title can be for logistic regression confusion matrix, and we could get a font size for it, probably a 12. I don't know, 12 may be big, but 8. Okay, we'll try to work with this font size based on our output. If that is big, let me first do like 5. It might be very big. Now then we just get the snn dot subplot, no, snn dot itmap. So itmap will be now to the CM, because we want it to get for logistic regression from this model that we plotted. So it's going to be CM underscore LR, which is on that variable. Then annotate to true. Then annotate to true. Then the CMAP, color to let's pick colors. We've used colors before here. Could use this color here. That's number 4. 1, 2, 3, 4. So the CMAP color can be that. Then we could use the FMT to D. Don't worry about that parameter, I'll explain it. Then the CBAR to false. then annotate. So let's look at the KWS, which is the keywords. Annotate the keywords equals to, let's do a dictionary here to get the size. The size will be 24 and close the bracket. The spelling of false. Okay, I hope this is okay. We could first sample this and see. This one will be this one is going to be the confusion matrix. This is going to be logistic regression confusion matrix using heat map. Yeah, so let's run this. If it works, so the CMLR is not defined. Okay, so this is literally how it's going to be, but let's first try to fix this error on the heat map cell, which is not defined. But we have defined it here. Maybe you just need to run everything again. So the annotate error is the 1, 2, 3. Okay, let's go to the font. Okay, so the CMAP just a key error, so we just want to fix this keyword error, which I'm sure we will fix shortly. Okay, so it's SNN heat map CML annotate to true, CMAP the color, FMT to D, CBAR to false, annotate keywords, size that. Okay, why is it failing? Oh, it's not something difficult, but we're gonna fix that. Let's just try maybe to use like a green. Okay. Okay. Let's try to redo this code. Sorry for that. Okay. I'm just going to repeat everything. This is so annoying. I think I can try to recover back this code and see. Could I recover back this code and see? Okay. Oh. Okay. Okay, so let's try to this is the code for plot confusion matrices using heat map. So we have it for this is going to be heat map for heat map for logistic regression. Now we could duplicate this code, then just keep changing. Okay, so let's just have our plt dot show. Okay, so we can now duplicate this code, and so this time round we will have it for k okay, we will have it for k nearest neighbor. So for K nearest neighbor confusion matrix, so K nearest neighbor is KNN. So we have to change this to KNN. On when you run, oh, it's like two of them are there. Okay, we just need to change something here briefly in the subplot to be 2. Okay, that looks fine. So let's try to get it for the support vector machine. So for support vector machine confusion matrix, so this is going to go to 3 in this parameter for the sub 3. Okay. Okay, so we have the first one here, logistic regression. So you can see the true positive and true negative here. Then you can also get for the heat map for this is going to be 4, and it's going to be for naive, Bayes confusion matrix. So you have the naive Bayes confusion matrix. Then you can also get for the 5th one, which is the decision tree. Decision tree. Decision tree classifier. So it's going to be 5. Okay, so the naive Bayes is not this. We just need to change this a bit. It's NB. Then the decision tree is the DTC. Then the support vector is the SVM. Okay, Then the last one is going to be, we could check this out. Okay, then you could now get the last one, which is going to be so the last one is going to be it's going to be random forest confusion matrix, which is going to be the last one. And it's going to be 6, and it's going to be RF. Okay, so could run this. Yeah, so basically here you would see that the confusion matrix is able to get for us the performances of these modules. So you realize the one which looking at the false positive or true positive, look at this performance of these models. Now to summarize this, I know the recording has gone too long, I think probably around 2 hours. I just want to summarize and say confusion matrix is just to allow you just to get I'm just going to use this multi-line comment. I'm not going to type this now. Let me just give it to you here. Okay. So the confusion matrix allow us to understand how well the model is performing and identify specific areas of improvement, especially when it comes to dealing with imbalanced data set or when the different types of error have different costs or consequences. So this is going to be our last video or training on the machine model. If you watch this video up to this point, please click on the like. If you have anything that you feel you have not understood, please comment down in the comment section. I'll try to, if anything that you have not understood in the comments, please just leave a comment. I'll try to respond to all your comments in the chat. But please subscribe, like, make the algorithm happy by liking this video, because it has taken a lot of effort, time to come with a complete comparison of these modules using machine learning. So this is going to be probably my okay, I'll do one more video to complete the machine learning which are there, just in case I've not discovered and I've not covered anything. But I'll try to do one more video, maybe to patch up maybe the bootstrap aggregations, cross validations, and then the probably those are the only ones that are the grid search on those modules. Then also to remind you, I've not covered Python SQL, how to deal with SQL in Python, how to delete, upload data, drop data. Then also Python, MongoDB, how to insert, find, query, delete, drop collections. And then the last one I've not done with the Beautiful Soup. Maybe I will do some Beautiful Soup web scraping in one of the videos. But this, I know this is the long video, but please like, subscribe. If you have any comment, finish this and then send me your work, and try to create a final list for all your work in a folder for morning and afternoon, and then call it recess, and then submit it to the GitHub. I'm reluctant of putting this code on the GitHub because you guys are going to just reproduce this code and send it back to me. But otherwise, this brings us to our journey of machine learning model on the different algorithms like logistic regressions, KNNN, the K nearest neighbor, the SVM, support vector machine, naive Bayes, using the Gaussian naive Bayes and decision tree classifier, and random forest classifier, okay, and then the confusion matrix. So this is it all. Thank you for watching this video. I hope if this video has helped you, like, share. Catch you on the next episode. Bye bye. Next week I'll be doing web development using Django and Flask. That would be the end of our research program. Bye bye.